let's look at the algebraic equation. 2 groups of x plus 1 is equal to 10. So we want to solve for this unknown. This x is unknown to us right now. We want to figure out what is it. So there's a variety of different methods we could guess. We could plug in a 1 for x and check, or 2 or 3. I could guess 3 maybe. 3 plus 1 is 4 times 2 is only 8. So we could keep guessing like that. But another great way is to model it. So we're going to use our balance. We're going to model it on our balance. Here's x plus 1. I'm going to put an x plus 1 on that side. And now it says I need 2x plus 1, so let me get another x plus 1. There's my second x plus 1. I'm going to put that on that side there. And that is supposed to be equal to 10. 2, 4, 6, 8, 10. And indeed it is equal. These are the same level right now. You can kind of see that. Might be, again, this balance isn't super expensive, so it's not perfect, but we can see these two sides weigh the same. Beautiful. They are balanced and equal to each other. First thing I want to do is rearrange this side a little bit. I had 2 groups of x plus 1, but I can see what I really have is 2 x's and 2 more 1's. I really have 2 x's and 2 more. And in fact, that's what we're doing in algebra with this idea of the distributive property. 2 times x is 2x, and 2 times 1 is 2. So that's the left-hand side. And on the right-hand side, we've still got 10. Now, I know I reached my hand in there and rearranged some things, but I didn't really change the value of the left-hand side. Similarly, I did distribute this 2, but I didn't really change the value or the weight of the left-hand side. So it's still in balance. Now I am going to do some changing. But when I change one side, I'm going to make sure to change the other side in the same way. What I can see in my equation and in my balance here is that if I take out 2 from this side and 2 from this side, I think it's going to stay balanced. So we try. Yep, still balanced. I took away 2 from this side, and I also took away 2 from this side, and it is still balanced. Now what I have left is 2x on the left, because 2 minus 2 is just 0, so I have 2x on the left. And on the right, I had 10, but I took 2 away, so now I have 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to realize that I want to know what 1x is. And I have 2 x's here, and I have 4 here. So I'm going to take half of this bucket away, this 4, this x here, and I'm going to take half of this bucket away, this 4. So I'm gonna cut in half what's in there, and it's still balanced. So now I think I know what x is. I took half of this bucket, and I took half of this bucket, and it's still balanced. And on the right, I can see I have 4. 8 divided by 2 is 4. And on the left, I just have an x. Actually, I'm not even going to write the 1. 1x is just x, right? So now x is 4. I can see that x is by itself over here. It's isolated completely. And I know what's in there because there's 4 over here. And if there's 4 over here, there's got to be 4 inside there because the foil's not very heavy at all, right? So I think x is 4. And this x must be equal to those 4. Let me see. Moment of truth. X was previously unknown, but now we think we know it, and we're going to check. Yay! 4. There are 4 here that balanced with that, and this x has to be 4 as well. Yep. These 4 balanced with these 4, and then they both had an extra 2 to start with. This was like this to start with. This was our 2x plus 2, and this was our 10. Indeed, x was 4. Yay! Thanks for doing math with me. You can use the same concept for a lot of different equations. It's harder to model negative numbers. Like if this was 2x minus 2, it would be hard to model a negative 2. However, when you're doing this physical balance, any positive numbers and also whole numbers work pretty darn well. Then once you understand this concept with the whole positive numbers, you can also extrapolate and apply it to both negative numbers and fractions or decimals as well. Happy mathing!